Glass fiber reinforced concrete cladding, the solution of choice for shaping the future. Glass fiber reinforced concrete, GFRC, has become a familiar product to the construction industry. One of the most innovative materials available, GFRC facilitates unprecedented opportunities for design of the most visible element of a structure, its cladding. GFRC is rapidly becoming the material of choice for a broad range of building types. GFRC is a Portland cement-based composite reinforced with randomly dispersed alkali-resistant glass fibers. The fibers serve a purpose similar to the reinforcing steel in reinforced concrete. The glass fibers add flexural, tensile, and impact strengths, allowing the production of strong, thin, lightweight architectural cladding panels for all types of buildings. GFRC was first introduced to the world's building industry in 1969, starting in the United Kingdom and Europe and closely followed by the US, Middle East, and Southeast Asia. It boasts over 30 years of proven performance. GFRC is a quality material with initial plasticity that is incredibly responsive to the designer's creative needs. Designers can choose from a variety of sculptured shapes, from reveals to complex rectilinear and curvilinear shapes, such as short radius curves, wide sweeping arcs, or 90-degree angles with minimal effect on panel cost. Optimum economy occurs, however, when reuse of forms is maximized with product repetition. Not only can traditional architectural styles or intricate ornamental details be faithfully reproduced, but also complex surface designs or profiles can be incorporated in either relief or intaglio. The shape and final finish of a building when using glass fiber reinforced concrete is limited only by the architect's imagination. GFRC's increasing popularity results from the manufacturer's ability to meet demands for more sophisticated custom-designed solutions. Architects are designing creative facades by taking full advantage of the wide variety of GFRC components available. These include solid walls and window wall units, spandrels, cornices, interior ceiling panels, columns, soffits, fascias, domes, and mullions. Versatile GFRC can also be used as mansard roofs and interior feature panels. The sculptured shapes that are possible with GFRC window wall panels allow for the design of many types of shading devices for window areas, including vertical and horizontal shades. For example, profiled window wall units can form deeply recessed window frames that provide a high degree of sun shading and minimal solar heat gain without reducing natural light and view. GFRC is manufactured by simultaneously hand-spraying a Portland cement sand admixture slurry and glass fibers into forms of the desired shape and size. The slurry is mixed in a high-shear mixer and fed via a pump to a concentric spray gun, which chops the glass fiber strands into approximately 1 1/2 inch lengths and injects them into the slurry. The GFRC skin has two distinct layers, a mist or face coat and backup layers. The mist coat, consisting of a cement sand slurry, may be sprayed on first to provide cover for the glass fibers on the finished face. Consolidation of the face coat is done to remove any entrapped air and to impart a void-free face surface. Prior to initial set of the mist or face coat, the GFRC backup is sprayed. Several layers of the composite are deposited and compacted until the required backup thickness, usually 1/2 to 3/4 inch, is achieved. Consolidation between layers is done with rollers, which compact the backup mix, remove entrapped air, and bond the face mix to the backup glass fiber mix. Quality control checks on thickness are made regularly during the spraying operation to ensure a uniform thickness of the finished panel. Molds into which GFRC are sprayed can be made of plywood, concrete, steel, plastic, polyester resins reinforced with glass fibers, plaster, foam plastic, GFRC, rubber, or a combination of these materials. The molds are responsible for giving the panels their final shapes. Fabrication economy is determined primarily by the extent of casting repetition and by the piece sizes, particularly if the molds have shape. Glass fiber reinforced concrete manufacturers have responded to the desire for more color choices by offering a wide variety of colorful ingredients. Color variations are achieved through selection of Portland cement, color pigments, or different colored aggregates. Throughout manufacture, stringent quality control procedures assure proper spray rates of slurry and fiber. The slurry flow rate, bucket test, and the fiber roving chopping rate, bag test, are used to determine if the fiber content being sprayed is within limits. Sample coupons are prepared in order to perform fiber content tests or washout tests. Cured coupons are used to determine bulk density, absorption, and flexural strength. Typically, reinforcement of the skin is required for panels of appreciable size. These stiffeners can be a single skin rib or a box rib. Plant-attached frames comprised of steel studs or structural tubes are the most common and economical method for stiffening. These frames also provide a means for connecting to the building structure. Prior to the manufacturing of the panel, a frame of light-gauge steel stud or structural tube is welded. The frame is positioned over the GFRC skin as soon as the skin has been sprayed to the proper thickness. L-shaped flex anchors, pre-attached to the frame by welding, are attached to the skin with additional GFRC material known as bonding pads. The flex anchor enables the GFRC skin to move slightly to compensate for thermal and moisture movement of the GFRC face without undue restraint from the frame. Sometimes gravity anchors positioned along the bottom of the panel are used in addition to the flex anchors. This added support helps to transfer the weight of the skin to the steel frame. Gravity anchors may be trussed round bars or flat bar tees welded to the frame and attached to the GFRC skin in a manner similar to flex anchor attachments. The following morning, after the GFRC panels meet a required minimum strength, the panels are demolded or stripped from their molds. The panels are then moved to the finishing area and the molds are reassembled as the daily process starts again. GFRC panels can be customized in virtually any color, form, or texture to meet aesthetic and practical requirements of modern architecture. Since GFRC is sprayed on the form, a consistent texture can be achieved on highly articulated profiles. Unlike other materials, GFRC offers excellent possibilities for the architectural use of multiple colors and textures. The fine matrix of GFRC allows production of delicately detailed surface patterns in low relief at reasonable cost. It is also able to reproduce the appearance of natural stone, terracotta, and even metal panels. Panel finishes can be achieved by sandblasting, water blasting, or other techniques. After finishing, panels are stored until shipment to the project site is required. Also, natural stone veneers may be used in creating an almost infinite number of patterns. Thin veneers of natural stone are panelized utilizing the GFRC skin and frame for support, resulting in ease of transportation and installation. A major benefit of the lightweight GFRC panels is the ability to ship many panels on a single load. This allows for economical transportation over long distances. Panels can be cast in sizes up to approximately 12 by 30 feet. That limitation arises not from structural restraints, but from transportation logistics. On single large steel frames, the continuous GFRC skin should span no more than 20 feet without including a skin joint. After panel installation, window frames are screw attached to head and sill members of the panel frame or to a separate framing system. The frames also provide a cavity for installing insulation, fire safing, and utility conduits. Drywall can be mounted on furring channels attached to the panel frames. Today, GFRC is used to clad a wide range of structures from single-story buildings to skyscrapers. A building's exterior creates a visitor's strongest impression and a company's most enduring image. Shown here are some of the thousands of buildings in all climatic conditions with unique distinctive facades that have been created with glass fiber reinforced concrete.